In this section, you're going to learn how to write complex queries in SQL. Mostly, we're going to revisit subqueries that you learned about earlier in the course. A subquery is a select statement that is within another SQL statement. In this section, we're going to take a closer look at these subqueries. We're going to work on lots of examples that help you master writing complex queries. Now, before getting started, I want you to restore all of our databases to their original state, because earlier in the course, we added some new records, we updated existing ones. I want to make sure that going forward, we both have the exact same data set. So what I show you in these videos look exactly the same on your computer. So here in MySQL Workbench, on the top, go to the File menu, and then open SQL Script. Then browse to the folder where you stored all the scripts for creating these databases. In case you lost that folder, simply go back to the first section. There is a lecture for downloading the scripts. Now, in this list, open Create Databases. This will recreate all of our databases. So we will have the exact same data set. Now, to execute this, either click on this icon here or use your shortcut. There you go. All of my databases are restored to their original state. Beautiful. Now let's jump in and get started. All right, let's start this section by writing a simple subquery. So in our SQL Store database, we want to write a query to find all the products that are more expensive than lettuce. And here the ID of lettuce is 3. So we need to write a query like this. Select everything from the products table where unit price is greater than. Now here we need to get the unit price for lettuce. So this is where we write a subquery in parentheses. Let me close the navigator panel. That's better. So here inside the parentheses, we select the unit price column from the products table where product ID equals 3. When MySQL tries to execute this query, first it will evaluate our inner query or subquery. So it will get the unit price for lettuce, and then it will pass the result to our outer query over here. So let's execute the query and see what we get. These are the 2 products that are more expensive than lettuce. So here's one way to write a subquery. In this example, we have coded this subquery inside the where clause, but we can also write a subquery in the from clause or in the select clause, as I will show you later in this section. But before we get there, I have an exercise for you. In our SQL HR database, write a query to find all the employees who earn more than average. It's a really good exercise to get your hands dirty with subqueries. All right, so first we're going to use our SQL HR database. Then from the employees table, you want to select everything where salary is greater than. Now here we need to calculate the average salary of all employees. So that's where we need a subquery. We add parentheses, and inside this parentheses, we select the average of salary from the employees table. Now let's execute this query. So these are the employees who earn more than average. In this lecture, you're going to learn how to write a subquery using the in operator. So in our SQL Store database, let's say we want to find the products that have never been ordered. How can we solve this problem? Well, let's take a look at our tables. You know that in the order items table, we know how many times each product has been ordered. So to solve this problem, first we need to find all the products in this table, and then we'll write another query to return products that are not in this table. So back to our query window. First, let's select the product ID column from the order items table. So these are all the products that have been ordered. But as you can see here, we have duplicates. So we can simplify the result by using the distinct keyword. So back to our select clause, we add the distinct keyword here. Let's execute the query one more time. Now we have the unique list of products that have been ordered. Beautiful. Now we need to use this query as a subquery inside another query. So we want to go to the products table and select everything where product ID not in this list. So we're going to wrap this query with parentheses to convert it to a subquery. Let's indent it. That's better. We add parentheses here. Let me close this window and here. So our subquery returns the unique list of products that have been ordered. Now we get this list and pass it to our where clause. Let's execute the query. And product number 7 is the only product that has never been ordered. So in this example, our subquery is returning a list of values. In contrast, in the last lecture, the subquery that we wrote returned a single value. For example, we calculated the average salary of all employees and then returned employees who earned more. In that case, our subquery returned a single value, and we use that with a comparison operator in the where clause. In this example, our subquery is returning a list of values, but we can also write a subquery that returns a table with multiple columns. You will see that later in this section. Now for exercise, in our SQL invoicing database, I want you to write a query to find the clients without invoices. It's pretty straightforward. You can knock it out in a couple of minutes. All right, in our SQL invoicing database, we have this invoices table, and in this table, we have the ID of each client. So first we need to get the unique list of clients, and then we'll use that list to find clients who don't exist in this list. So back to our query, let's select distinct of client ID from the invoices table. Execute. These are the clients with invoices. Now we need to select everything from the clients table where client ID not in, and then we'll use our subquery like this. Pretty easy. Let's execute the query. So we only have one client who doesn't have an invoice. Quite often we can rewrite a subquery using a join and vice versa. For example, here's the query that we wrote as part of the exercise in the last lecture. So here we are selecting the client without invoices. Now we're going to rewrite this, but instead of using a subquery, we're going to use a join. So we want to select all the clients, and then we want to join these clients with the invoices table. Now earlier you learned that we have two types of joins, inner joins and outer joins. If we do an inner join, we'll only get the clients who have an invoice. If we do an outer join, or a left join more accurately, we'll get all the clients whether they have an invoice or not. So as you can see, we can rewrite a subquery using a join and vice versa. So which approach should you use? Well, that depends on a couple of things. One is performance and the other is readability. Later in the course, we talk about execution plans, so you will learn how to write a query that gets executed faster. But assuming that both these queries have the same execution time, you should go for the query that is most readable. In this particular example, the first query is more intuitive because it better aligns with the problem you're trying to solve. Find clients without invoices. So you're finding clients who don't have an invoice. Understanding this query is easier. So left join here is a little bit of distraction from our problem. But this is not always the case. Sometimes you will see that using a subquery can make your query too complex, and in those cases, it's better to use a join. So always pay great attention to the readability of your code. All right, here's a great exercise for you to practice what you learned in this tutorial. In our SQL Store database, write a query to find the customers who have ordered lettuce. And as you remember, the ID of lettuce is 3. In your select statement, select customer ID, first name, and last name. Now we can solve this problem using both a subquery and a join. So as part of this exercise, I want you to come up with both solutions and pick the one that is more readable. You will see my solution next. All right, first I'm going to solve this problem using a subquery. So I want to select everything from the customers table, where customer ID in. Now here in the subquery, we need to return the ID of customers who have ordered lettuce. So we need to go to our order items table, select everything from order items, where product ID equals to 3. Now in this table, we don't have the customer ID. So we need to join this table with the orders table to get the customer ID. Let's give it an alias and then join it with the orders table using the order ID column. And then instead of selecting everything, we select o.customer ID. So this is how we solve this problem using a subquery. Now let's execute our query. We should get these 3 customers, number 8, 2, and 10. Beautiful. Now I'm going to solve this problem using a join. So I'm going to join the customers table with the orders table and then order items. Then we'll filter and get only the records where product ID equals to 3. So I'm going to open up a new query window. Here we're going to select everything from the customers table. Do a join with the orders table using customer ID. And one more join with the order items table using the order ID column. Now we want to apply a filter. So where order item.product ID equals to 3, let's execute our query. See what we get. Note that because customer number 2 has ordered lettuce twice, this record is duplicated here. We don't want duplication, right? So here, instead of selecting everything, we do a distinct of customer ID, and then we'll pick the first name and last name columns. Let's execute the query one more time. All right. Now we have the same result as before. Now, actually, I made a mistake in my first query. So instead of selecting everything here, we should select customer ID, first name, and last name. That doesn't really matter. Now, compare this query with this other query. In my opinion, the second query is more readable. It's more meaningful because there is a natural relationship between customers, orders, and order items. So in situations like that, quite often we use joins. And here our filter clearly explains what customers we're looking for. Customers who have bought product number 3. So I personally pick the second solution over the first one. All right, now let's select invoices that are larger than all invoices of client 3. Once again, we want to simplify this problem. So first, let's get all the invoices of client 3. So in our SQL invoicing database, first I'm going to select everything from the invoices table where client ID equals to 3. Let's execute this query and make sure we get the right result. All right, so here are all the invoices of client 3. As you can see, each invoice has a total amount. Now look at invoice number 15. The total amount is $167. So this is the largest invoice of client 3. Now we want to change our query to get all invoices that have a total amount greater than $167. So first we want to change this query to select max of invoice total. Let's execute the query one more time. All right, now we get $167. Beautiful. So now we can use this query as a subquery to select all invoices with total amount greater than $167. So we want to select everything from the invoices table where invoice total is greater than, and this is where we use our subquery. So let me indent these 3 lines. That's better. Let's execute the query one more time. There you go. So these are the invoices that are larger than all invoices of client 3. Now there is another way to solve this problem using the all keyword. Let me show you. So I'm going to open up a new query window. So once again, we want to select invoices that are larger than all invoices of client 3. So we can convert this sentence to a query like this. Select everything from the invoices table where invoice total is greater than, then we write our subquery Here we want to select the total amount for all invoices of client 3. So select invoice total from invoices where client ID equals to 3. However, when we run this query, instead of getting one value, we're going to get multiple values because client 3 has multiple invoices. Let's take a look. So there you go. These are the total amounts for all invoices of client 3. Now, in this query, we want to select invoices that have a total amount greater than all these values. So we prefix our subquery with the keyword all. When we give this query to MySQL, first it will execute this subquery. This subquery returns a list of values like this. Let me just temporarily delete this and show you the amounts. Like $150, $130, $167, and so on, right? Then MySQL is going to look at the invoices table. For each row, it will compare the invoice total with these values. If the invoice total is greater than all these values, that row will be returned in the final result set. So this is how the all keyword works. Now I'm going to revert this back to what we had earlier. So here's what you need to take away. Sometimes your subqueries return a single value. Sometimes they return a list. Sometimes they return a table. In our first implementation, our subquery returned a single value. That was the max of invoice total for client number 3. When we execute this query, we get $167. So in our main query, we can compare invoice total with $167. In contrast, in the second implementation, our subquery returns a list of values. In this case, if we don't add the all keyword here, MySQL will not be able to compare invoice total with all these values. So that is why we'll have to prefix this subquery with the all keyword. So these two implementations are interchangeable. Wherever you have the all keyword, you can rewrite that query using the max aggregate function. In my opinion, both these queries are readable. Some developers prefer to use the max function. The others prefer to use the all keyword. In this particular case, I personally think this second implementation better aligns with the problem at hand. So I prefer this second implementation, but they're both equally good. In the last lecture, you learned about the all keyword. In this example, we're only getting rows where invoice total is greater than all the values returned by this subquery, okay? Now in MySQL, we also have the any or some keywords. They're equivalent. And with this, we'll get rows where invoice total is greater than any of these values returned by this subquery. Let me show you an example of this. So let's say we want to select the clients with at least 2 invoices. How can we solve this problem? Well, first we need to know the count of invoices for each client. So we can write a query like this. Select client ID and count of everything from the invoices table, group by client ID. Let's execute this query. There you go. So next to each client, we know the count of their invoices. Now we're only interested in clients that have at least 2 invoices. So here we want to apply a filter using the having clause because we want to filter after grouping our data, okay? So having count of star greater than or equal to 2. So with this, we get clients 1, 3, and 5. Beautiful. Now here we don't really need this column, the count column. We only want to know the client IDs. So we can remove this from our select clause. Let's execute the query one more time. So we only have the client IDs here. Beautiful. Now we want to select the clients with these IDs. That is very easy, right? So we go to the clients table and select everything where client ID is in any of the values returned by this subquery. Like this. You've already done this before, right? So these are our clients 1, 3, and 5. Beautiful. Now there is another way to write this query. Instead of using the in operator, we can use the equality operator and prefix the subquery with any. So if client ID equals to any of the values returned by this subquery, that client will be returned in the final result. So equal any is equivalent to the in operator. Which approach you choose is entirely up to you. They're both equal. Here's another interesting query we're going to work on. We want to select employees whose salary is above the average in their office. For this demo, we're going to use our SQL HR database. So let's have a quick look at the employees table. There you go. So in this table, we have the salary for each employee, as well as the office in which they're located. So in Office 1, we have 4 employees. We need to find the average salary of these employees and then return only the employees who earn more than average. Similarly, we're going to find the average salary of employees in Office number 2 and return the employees who earn more than average. So we're not dealing with a constant average across the entire organization. We want to calculate the average salary for each employee. In other words, if I write a pseudocode for this problem, my pseudocode is going to look like this. For each employee, calculate the average salary for employee.office, and then return the employee if salary is greater than the average. This is what we call a pseudocode. It looks a little bit like a code, but it's not code. It's just plain English. Now we should convert this to a query. So we want to select everything from the employees table where salary is greater than, and this is where we need to write our subquery. In our subquery, we need to calculate the average salary for employee.office. So we select average salary from employees, but we don't want to calculate the average salary for all employees. We want to apply a filter here. We only want to get the employees in the same office. How can we find these employees? Well, we can give this table an alias like E, and then write a where clause like this, where office ID equals E.office ID. So here's the tricky part here. In both the outer and the inner queries, we are using the employees table. So to get the employees in the same office, I've qualified this office ID column by prefixing it with the table alias. So this is what's going to happen when MySQL executes this query. It's going to go in the employees table. For each employee, it's going to execute this subquery. It will calculate the average salary for employees in the same office. Then, if the salary of this employee is greater than the average, it will return that employee in the final result. Then it will move on to the second record. Once again, for the second record, it's going to calculate the average salary for all employees in the same office. This is what we call a correlated subquery, because in this subquery, we have a correlation with our outer query. We are referencing the alias from the outer query, that is E here. In contrast, all the subqueries that we wrote earlier were uncorrelated subqueries. So, for example, in the last lecture, we wrote this query to find the clients with at least 2 invoices. In this subquery, we don't have a reference or a correlation with the outer query. So MySQL will execute this subquery only once. In this case, this subquery returns a list of client IDs. So that list will be passed to our where clause in the outer or main query. In contrast, when we use a correlated subquery, this subquery gets executed for each row in the main query. So for this reason, correlated subqueries can sometimes be slow. The more data you have, the more overhead your query is going to have, and the slower you're going to get your result. Having said that, correlated subqueries are very powerful and they have a lot of applications in the real world. For your exercise, we're going to go to our SQL invoicing database and get the invoices that are larger than the client's average invoice amount. Let me explain what I mean. So let's have a quick look at the invoices table here. As you can see, each client can have multiple invoices. So client number 5 has these invoices. For each client, we need to find the average invoice amount. That is the average of invoice total column. And then we only want to return the invoices that have a larger total amount. Now we want to repeat this for each client. So this is where we need to use a correlated subquery because we're not dealing with a single average across the entire table. So go ahead and do this exercise, then come back, continue watching. All right, we're going to start by selecting everything from the invoices table where invoice total is greater than, and here's our subquery. We select the average invoice total from the same table where now we only want to get the invoices for the current client. So we give this invoices table an alias like I, and then use that in our filter. So where client ID equals I.client ID. Pretty straightforward. Let's execute this query. So we should get invoices 2, 4, 5, 8, 9, 15, 16, and 18. In this lecture, we're going to write a query to get the clients that have an invoice. You should already know two ways to solve this problem. We can use the in operator or a join. Let me show you. So we select everything from the clients table where client ID is in, and now we write our subquery. We select the client ID from the invoices table. Now we could also apply the distinct keyword here. So we're only getting the clients that have an invoice in the invoices table, okay? The other approach is to use a join. So if we do an inner join between the clients table and the invoices table, we only get the clients that have an invoice. Now let me show you a third way to solve this problem using the exists operator. So in a new query window, I'm going to write the same query, but in a slightly different format. So select everything from the clients table where exists, and here in our subquery, we write select client ID from invoices table where the client ID column in the invoices table equals to, now we should give an alias to this client's table. So c.client ID. So once again, here we have a correlated subquery because we're correlating this inner query with this outer query. We're referencing the client's table in our subquery. However, in our where clause, we're not referencing a column. We're using the exists operator to see if there is a row in the invoices table that matches this criteria. So when MySQL tries to execute this query, for each client in the clients table, it will check to see if there exists a record that matches this criteria. Now here's the difference between this query and the query that we wrote earlier. When we use the in operator, MySQL will execute this subquery and it will return the result to our where clause. Now in this particular case, that result is a list of 4 client IDs, right? So when MySQL executes our subquery, our main query will look like this. 1, 2, 3, 5. These are the client IDs that have an invoice. Now, what if in this table we have hundreds of thousands or millions of client IDs that have an invoice? We're going to end up with a very, very large list, and this will have a negative impact on the performance. In situations like this, it is more efficient to use the exists operator. When we use the exists operator, the subquery doesn't actually return a result to the outer query. Instead, it will return an indication of whether any rows in the subquery matches this search condition. Do we have a client by this ID in the invoices table or not? So as soon as it finds a record in this table that matches this criteria, it will return true to the exists operator. And this exists operator will include the current record, the current client in the final result. So here's what you need to take away. Back to the in operator. If the subquery that we wrote after the in operator produces a large result set, it is more efficient to use the exists operator. Because when we use the exists operator, the subquery doesn't actually return a result set to the outer query. Here's your exercise for this tutorial. In our SQL Store database, find the products that have never been ordered. This is a good case for using the exists operator. Imagine you have a website like Amazon. On Amazon, we have perhaps hundreds of thousands of products and millions of orders. If you want to use the in operator here, our subquery is going to return a large result set. In this case, it's more efficient to use the exists operator. So go ahead and write this query. You will see my solution next. All right, so first we're going to select everything from the products table, where now if you want to use the in operator, our where clause would look like this, where product ID not in, and then in our subquery we select product ID, product ID from the order items table. Let's execute the query. So product number 7 is the only product that has never been ordered. Now we want to rewrite this query using the exists operator. So we're going to change our where clause like this, where not exists. So I'm using the not operator in addition to the exists operator. Now here we need to write a correlated subquery. So we give this table an alias like P, and then check to see if we have a product by this ID in the order items table. So where product ID, that is the product ID column in the order items table, equals p.product ID. So when MySQL tries to execute this query, for each product, it checks to see if this condition is true. If you have a product by this ID in the order items table, this subquery will return true. Now, because we have the not operator here, true will end up becoming false. So that record will not be included in the final result set. So far, you have only used subqueries in the where clause of a select statement, but we can also use subqueries in the select clause. Let me show you. Let's say we want to generate a report like this. So here we have 4 columns: invoice ID, invoice total, invoice average, which is the average of all invoices in our invoices table, and the difference between the invoice total and invoice average. Let me show you how to write a query to produce this result. So we're going to start by selecting the invoice ID and invoice total columns from the invoices table. Next, we need to calculate the average of all invoices in this table. So this is where we write a subquery. We start with our parentheses, and inside this parentheses, we write a subquery. So select average of invoice total from the invoices table. And then we give it an alias like invoice average. Let's execute the query. So this is what we get. We have the invoice ID, invoice total, and invoice average. Beautiful. Finally, we need to add the last column to calculate the difference between the total and the average. So here we can write an expression like this: invoice total minus. Now here we cannot add invoice average. In other words, we cannot use a column alias in an expression. One solution is to copy this entire subquery and put it here. But that looks a little bit too long, and I don't like this repetition of our query. So here's a better way. We can convert this invoice average to a subquery. So we put it in parentheses and then simply select it here. Now let's execute the query one more time. There you go. So we can see the difference, but look at the name of the column. It's set to the exact expression we have used here. So let's rename that to difference. That is better. So subqueries are not limited to where clauses. You can also use them in the select clause as well as the from clause, which I will show you in the next lecture. All right, here's your exercise for this tutorial. Write a query to produce this result. Here we have these columns: client ID, name, total sales for each client, which is basically the sum of all the invoices issued for each client. We also have the average sales. So this is the average of all invoice totals. And finally, the difference between these two columns. Note that for client number 4, we don't have any invoices. That's why we have null in these two columns. All right, I'm going to start by selecting the client ID and name columns from the client's table. Next, we need to get the total sales for each client. So here we write a subquery, select sum of invoice total from the invoices table, where the client of this invoice equals the current client. So here we have to write a correlated subquery. So we need to assign this table an alias like C, and then write our search condition like this, where client ID equals c.client ID. So this subquery returns the total sales for each client. Let's give it an alias, total sales. Next, we need to calculate the average sales across all invoices. That is pretty easy. So we select average of invoice total from the invoices table and give it an alias like average. And finally, we need to calculate the difference between these two columns. Earlier, I told you that you cannot use these column aliases in your expressions. So here we can write a subquery like this. Select total sales minus average. Now let's give it an alias like difference. That's it. Let's execute the query. So here's the end result. Beautiful. In the last lecture, you learned that we can use a subquery in the select clause of a select statement. So this is a query that we wrote in the last lecture as part of our exercise. When we execute this query, we get this table. So we have the client ID, client name, total sales, average, and difference. Now currently we don't have a table like this in our database, but the data that we have in this, let's say, virtual table is very valuable because it summarizes a lot of data. Now we can get this table in memory and treat it like a real table in our database. We can join it with another table using the client ID column. We can filter the data here. We can group the data. We can do all sorts of things, just like how we use real tables in our database. So we can take this query and use it in the from clause of another query. Let me show you. So I'm going to write a very basic query, select everything from. Now, instead of referencing a table here, we can use the result of this query. So we can convert this query to a subquery. So let's remove ... Here we add parentheses and then indent our subquery. This is not required, but it makes our code more readable. And let's close the parentheses. Beautiful. So this is an example of using a subquery in the from clause of a select statement. Now, whenever we use a subquery in the from clause, we need to give the subquery an alias. This is required, whether we use that alias or not. So let's call this sales summary. Okay. Now let's execute this query. So we get the same result as before. So we haven't really achieved anything at this point, but we can filter this data. For example, we can write a where clause to return only the clients that we have an invoice for. So we don't want to return client number 4 because the total sales here is null. So back to our main query. Here we write a where clause where total sales is not null. Let's execute the query. Now, client number 4 is gone. Beautiful. We can also take this table and join it with another table. The possibilities are endless. Having said that, as you can see, writing a subquery in the from clause of a select statement can make our main query more complex. There is actually a better way to solve this problem using views. So we can take this query and store it in our database as a view. And then we can call that view sales summary. This will greatly simplify our queries. We'll look at views later in the course. So this is what I want you to take away in this lecture. Yes, you can write subqueries in the from clause of a select statement, but reserve it only for simple queries.